Hello everyone and welcome to my first YouTube video. My name is Abdelhalim Boumessaoud and I'm a second year mechatronics engineering student. This is my first project in artificial intelligence, and in this project I developed an AI system that classifies image as either a dog, a cat or a dog. And the classification depends on the algorithm used to make this prediction. I implemented several algorithms, different algorithms to compare the result. For example, one of the algorithms used is logistic regression. The user can choose which algorithm to input and preference. And the application offers ways to provide an image, either upload it from PC or paste the URL of the picture, the specified picture. This is the graphical user interface of our project. It contains image upload section and option to select one of the 7 algorithms for classification. Okay, first thing first, before starting, I'm gonna show you an example of how our project works. The first thing we do, we upload our image with the browse file. I already have this image in my downloads folder. I downloaded it from Google. And we choose which algorithm we want. We have KNN, naive Bayes, SVM. In my case, I'm gonna choose the XGBoost. And then we have this classify image button. We're gonna press it. And here is the result. Of course, the prediction is a cat. The confidence, 99.8%. That means our algorithm is very confident of himself. And the algorithm we used is the XGBoost. The last option provided is the correction mechanism. We have 2 options. If the prediction is correct, we press correct and save as a cat. And the prediction if is wrong, we choose wrong, it's a dog. When we press, of course, the prediction is a cat. When we press correct save as a cat, we navigate to our dataset, train, cats. Here is the dataset of cats. We navigate to the end, and here we are with our picture. It's uploaded to our dataset as a cat. Okay, so now let's get started with coding our project. I put all my files, Python files, and my dataset in one folder. I called it dataset. Here is my Python files, and here is the dataset. I split the dataset into two folders. I'm gonna tell you next into code why. Here is the training dataset. We have cats, dogs, etc. Now let's get started with the Visual Studio Code part. Okay, I created 2 files. One, I called it train all models. In this file, I'm going to train all the models we're going to use. We have 7 of them. I imported the necessary libraries. I used OS to work with folders and file path. And then I used NumPy for numerical operation. And then I used JobLib to save and load trained models. And then we have the skimage, which is the necessary library to read and resize and convert images to grayscale. And then I imported different machine learning algorithm. We have neighbors, k-neighbors, logistic regression, SVC, etc., from sklearn and XGBoost. Finally, and to import the accuracy scored to evaluate the performance of each model. Okay, we have the configuration party. In this part, we copy the path of our dataset. To copy the path of your dataset, you're gonna need to go to your dataset and click right, and you choose to copy as a path option. And then I divide it in two. We have the train folder and test folder, and of course I also defined image size as 64 by 64 pixel to ensure that all images have the same dimensions. And then we have our first function that we're going to create. It's the load data. This function is responsible for loading data, for loading the image from the folder, and then it will resize them and convert them to grayscale and flat them into one-dimension arrays. Of course, because our algorithms cannot see the image specifically, we're going to turn them into numbers, specifically one-dimension array. Here we define our three variables. We have the images, label, categories. The categories we have cat, we're going to transform to 0, I mean cat is equal to 0, and dog we're going to equal to 1. And here in the for, what this code does, it imports the images. For this for code import the images from the folder. That's what he does. And then he ensures the grayscale. He turned the in grayscale he turned the colors in the pictures to gray, because for our algorithms to read, he needs to clear all the colors and turn them into black and white. Not black and white exactly, but gray. And then he flattened them using the flatten function from 2D images to 1D array, I mean into numbers and lists. And of course, in this code we use the OC library that we imported into our first code, in the beginning of the code. And that's it. This is our first function that we use in our code. And then we're going to pass to load data. Here we divided the data into two. We have the train and test and train. This is the train that we're going to take our algorithms to train them. And then we have the test data that our algorithm going to use to test the performance of the algorithm. Okay, since we load our data, now we can define our models. The models we're going to use in our project are 7. We have nearest neighbor, logistic regression, naive Bayes, SVM and decision tree, and random forest, and finally XGBoost. For the SVM model, I enable probability estimation because it is needed to display the confidence percentage in this application. For that, for each algorithm, I created a file name. We have KNN. Of course, each algorithm I created his specific file. Here's our files. For KNN model, here is the file. Of course, we're gonna need them in the next for code. Okay, now let's pass to the last section in our code. This part of the code is the most important part of the training process. Here I use a loop to go through, specifically the for loop to go through each machine learning algorithm one by one, all 7 of them. First, the model is trained using the training data. As we specified before, we splitted our data into two sections. We have the train model and the test model. The train data takes almost 80% of the data set, and the test data takes almost the rest of them, which means 20%. During this step, the algorithms learn patterns from the images, such as shapes and textures, to distinguish between cats and dogs. And then We created this variable y prediction using the predict function. After training the model, is tested using the data. It has never that I said before. This test the model takes the part that I said before in our when I was explaining the dataset. Said we had to split our dataset into test functions. This now we take the test function to predict the model. This helps us to evaluate how well the model can generalize to new images. And then we passed. I created another variable called accuracy, which use the accuracy score function. This calculates the accuracy of the model, which represent the percentage of correct predictions. Each algorithm has its own accuracy score. This allows me to compare the performance of the different algorithms. That allows me to choose which one is better than the other. And then finally, I trained the model to save it to a file. Saving the model is important because it allows the application to use the trained model later without returning to them each time. Okay, this process is repeated all 7 algorithms using the for loop, which makes it easy to compare them and select the most suitable model for our project. At the end of the script, a confirmation message is displayed to indicate that the training process has been completed successfully. This means all the 7 models have been trained, evaluated, and saved. Now the training. Now I'm gonna run the model. I'm gonna test it. Now I'm gonna test if our codes run properly. I'm gonna use this line to test it. Train all models. This will run this file in Python. Here is the location of my code, and then now let's run it. We wait because this takes a little bit of time. Here we see that the data is being loaded to our algorithms. The data is being prepared. Now the training is started. We have nearest neighbor with 56% accuracy, 47, 49, 51% accuracy, 53% accuracy, 51 for tree model, and 51 accuracy for the random forest, which shows us that the best accuracy is the algorithm nearest neighbor with 56% accuracy. Finally, all models trained and saved successfully. That means our algorithm has been successfully run without any errors. Now that the training part is finished, I will explain the main application, which loads these models and provide a user interface for image classification. Okay, first thing first, as always, we import our libraries. These steps already imported them in the previous code. Already said that I imported all these libraries. Here, the new library that I imported is the Streamlit. The rest is the same as previously. Here, I configured the configuration part. I configured the title. This is the title of our site web, the classifier. Define path, already, all of this already explained it before in the train all models. This, and then the setting. Here I defined the the graphical user interface parameters, we have the setting, we choose algorithm and image source. Here we choose whether it's from PC or we paste our URL. Here we define the model, define a new function that define the model. This function, what does it define the model of our algorithm, and then we check the model if with the loop is if already exists. If it exists, you're gonna paste the model for was not found. If it's not exist, and then please run your training script to generate this model file first. These comments that I'm gonna paste if the model is exist. Helper function, and then I define another function that I'm gonna use, process and predict. This function almost does the same other function that I defined here, that load the data. This function, what it does, it resize, it upload the data from the dataset and resize it, then grayscale it, turn it to gray, flatten it, turn it to a list for first degree list, and then predict, except as previously as before in the train all model, we predict in the end of the code. Here we're gonna predict in the function. We're not gonna wait until the end. We're gonna predict here, and then we got the variables that we're gonna need. We have the probability and the confidence. We're gonna need this confidence especially for our site web. And then we save the image with order. This is a very important step because in our data set we have two trains specifically. We have cat and dog. The folder for the cat starts each file of a picture starts with a number. Before we have 1, 2, 3, etc., until 400. But in the dog folder we have the file of the picture starts. The picture's name starts with D, and then the one, then the letter D, and then 2, etc., etc., etc. That's why we need to define this. We're gonna say that if it was a dog, you're gonna start with D, and if it was a cat, you're gonna start with nothing. You just start put the number directly, and then you need to define that the number you're gonna do this for loop. What it does, it checks the highest number in our folder. For example, in the cat folder, you're gonna check the highest number, and you're gonna choose the next number of that highest number as an input, as a name of the picture that we're gonna save to our folder, for not mistaken or to well describe design our folder exactly. This is the for loop. Then I'm gonna save it, convert it to AGB and save it. And then we got the image input. This is where this special code, what it does, and this is where it comes the need to import the image straight to our site web. Here we have two options. You upload from your PC. You choose this option. What it does, it upload the picture from your PC, and this what it does. The second option, it upload the image from the internet. You just import the URL code of the specific image that you want to classify. So we have two options: upload from PC or paste URL. And then prediction and correction logic. Okay, now with the final section, the prediction and the correction logic. Once an image is loaded, it is displayed in the application when the user clicks the classify button using this code, if loop. The selected model analyzes the image and predict whether it's a cat or a dog, along with the confidence percentage. Then the function, this loop, what it does, it displays the result, and the algorithm used are then shown. And then with the second option, here, with the first option and the second option that we choose to confirm the prediction. If the prediction is incorrect, the user can correct it using the correction button, and the image is saved within the correct label. This and if it's wrong, we to save it in the opposite dataset. We're using the wrong button. This mechanism helps improve the dataset and allows the model to be retained later for better accuracy. And then now we're gonna run our code. Gonna know a new terminal. Write this line of code. I'm gonna run the Streamlit app 1py, and then we're gonna press enter. We'll wait a little bit. Here we are. Here is the final project. Our code is run properly. Everything is okay. No errors. So now let's test it. We press the button from the price file. We choose our picture. The picture I chose previously. And then we choose which algorithm we want to work with. We choose, let me choose this time the KNN, key nearest neighbor, upload from PC, and then I press classify image. The confidence this time is 80% because I chose another algorithm, the key nearest neighbor. The prediction is a cat. Good answer. And then the correction mechanism. Of course, the image prediction is correct. I press correct and save as a cat. The cat is saved correctly. And then I go to the dataset, rain, cat, and here we are with our cat. Okay, that's it. I think that's it. Here's our code. Everything works perfectly. All good. Thank you for watching to the end. See you next time. Goodbye.